Hi everyone, so welcome back to this tutorial. We're starting integration today. So we can start. So integration, in other words, is just called anti-differentiation, which simply implies that it's just the opposite of differentiation. Where you subtract in differentiation, in integration you're going to add. That's all it is. So for instance, you have a question like this. You have y being equal to x squared. So to find the derivative of y, you say 2. Your derivative of y is going to be 2x, because you're going to multiply these 2 times the coefficient 1 there, which gives you 2, and then you subtract 2 minus 1 there, you get x, like that. So the process of you now going back from this derivative, going back to the main expression there, is what we call integration. So that process is the one that we call integration, this process. So let's see what we have for today. So I'll start first by showing you the formulas that you can just master, or if you want you can derive them. So when you look at the first one here, we're saying x to the power n. So if you want to integrate x to the power n, you are going to add 1 to the power and then divide by the original, the new power. So you are going to say n plus 1 and then divide by the answer that you are going to get here. That's the integration. So for instance, when you have y is equal to x to the power 3, x to the power 3, like that. So to find the integral of y, which is just equal to the integral of x to the power 3, what this means is that, to find the integral of this x to the power n, our n here is 3, so we're going to add 1 to 3, meaning we're going to have x to the power 4, and then divide by the new power there, which is 4, and of course don't forget to put the constant c. So that is what that expression means. We move on to the second one here. So the second one, which is this one here, sine kx. So to differentiate sine kx, or to differentiate integration, you first differentiate the angle there. When you differentiate the angle, you get when you differentiate kx, you are going to get k. So you divide by the derivative of the angle, and then when you differentiate sine x, you are going to get negative cos. When you integrate sine x, you are going to get negative cos kx. So that's what you're going to have, and of course don't forget to add a constant, like that. So same applies to these derivatives down here. They're just the same. You just need to go through them. So the integral of 1 over x is equal to ln x. The integral of e to the power x is just the same. This e to the power x does not change. So the integral of the derivative of f prime, the derivative of fx over fx, you just get the ln of fx, but of course it's supposed to be in absolute value symbols, like that. So I think we can proceed. Let's see some examples of questions. So let me also talk about this. So for this one here, when you are integrating this, you simply differentiate the power, and then the derivative of the power is the one that you divide by the original function, and of course don't forget to add your constant c. Alright, let's now proceed. Let's see what's next. Alright, so this is question 1 from your tutorial sheet. So I'm going to start first by integrating this question here. So the integral of 12 over 23 with respect to x. This dx simply means with respect to x. So when you integrate 12 over 23, this is a constant, it's a number. So whenever you integrate a number with respect to a given variable, it means that that given variable would just be introduced to with the power 1. So what I'm trying to say is that when you've been given 2 and you've been told to integrate 2 with respect to x, it means that you're going to have your answer to be just 2x. You're going to introduce that variable with respect, to the power 1. So this is the integral of 2. So same applies to this part. The integral of 12 over 23 would just be 12 over 23, and then you introduce the x there, and of course don't forget to add your constant c. Yeah, so even here we're supposed to add the constant c. So let us proceed to the next question. So the next question here is saying find the integral of this. So for this question, since it has a lot of terms, we're going to be integrating each term at once. We're going to be integrating one term at once, at a time. So we can start. So the integral of 6 over x is just 6, and then when you integrate this, so this 6 over x is just the same as 6 times 1 over x. So when you integrate this with respect to x, we said the integral of 1 over x is just nothing but ln x plus c. So the integral of 1 over x there, it will just be ln x, like this. And then minus, when you integrate e to the power x, remember what we said, e to the power x does not change when you integrate it, it just remains the same. So what we're going to do is, when you integrate this will not change, to just be the same, to be 1 over 2 e to the power x. And then when you integrate 3, of course 3 is a number, so it will just be we are just going to have the x there introduced, and then don't forget to add your constant c. So this is the integral for this question there. So we proceed to the next question. So the next question here is saying integrate e to the power x squared minus 1. So what you do with this, we said when you're integrating this, you first integrate the power, and then you divide the whole function by you first differentiate the power, and then divide by the whole function, divide the whole function by that power. So what I'm trying to say is this: when you've been given e to the power any function f of x, you would write that function e to the power that function, and then you divide by the derivative of the power. So for this question here, we're going to find the derivative of the power there. First we're saying, so the integral of that is equal to this. So we're going to say, you write this, you are going to say, alright, yeah. So I was saying, for you to find the integral of this, you write first the whole function, which is e to the power x squared minus 1, and then divide by the derivative of the power there, which is just 2x. So this is the integral of this question here. Let us also move now to the next question, D. So this d here can also be written as the integral of x to the power negative 3, and then plus x to the power negative 2, then minus x squared. Then we're integrating this with respect to x. So the way you integrate this, we're going to be adding 1 to the power, just as we have here. So going to, as we have this here, this expression x to the power n, you add 1 to n and then divide by the new power. So you are going to have x, you add 1 to 3 there, you're going to have -2 here, and then divide by the new power, and then you say plus this x to the power -2, you add 1 to -2, you're going to get -1, then divide by the new power -1 there, and then so same applies here. I'm going to say minus x to the power 3 over 3, then plus c. So here now it's going to be equal to -1 over 2x, then you say squared, and then so when you divide -1 into that, you're going to have 1 over x, and then this is going to give you x to the power 3 over 3, and of course don't forget to put your constant c. So we proceed to the next question. This is the solution for this question. Proceed to the next question. So the next question there is E. So we, from our knowledge of indices, we know to say, from the knowledge of algebra that we have, we know to say this integral of 1 over the root of, let me write it properly. So this can also be written as the integral. Of course, we are integrating this with respect to x. So this can also be written as the integral of x to the power -12 with respect to x. So to integrate this, we're going to have x to the power +12, x to the power +12, and of course divide by the new power, which is 1 over 2, and of course don't forget to add your constant, which is equal to, so this can now be written as 2 root x, and then plus c. So this is our integral for that question. So the next question is f. So for f here, the integral of that can also be written as, we remove this 4 outside, which is 1 over x minus 1 dx. So the integral of this can just be written as 4 there, and then ln x minus 1. So this only applies, you can only do this when this x is raised to power 1. In short, when it's a linear equation. If it's a quadratic or any other equation, you need to use U-substitution or the change of variables. So this is the solution for that question. We proceed to G. So G is just the integral of that. So what we're going to do is, for this question, I'm going to say we're going to use U-substitution. It's called U-substitution because we're going to equate the denominator there to U. So it's going to be plus 2. So when you find du dx, you find that your solution there will just be equal to 2x. And then when you find du dx, you make dx subject there. So when you make dx subject, you are going to have your solution to be du over 2x. So you are going to have du over 2x as your dx. So in this expression where there is u, I'm going to put where there is x squared plus 2, I'm going to put u, and then where there is dx, I'm going to put this. So in short, what I'm trying to say is I'm going to have something like this: the integral of x, and then where there is, and then the integral of x over, so where there is x squared plus 2, I'm going to put u, and then where there is dx, I'm going to put 2x du, like that. So this, we can see that that x and that x will cancel, so I'm just going to remain with 1 over 2 the integral of ln, so 1 over 2 the integral of ln u, the integral of 1 over u, like that, with respect to u, which implies that the final solution will now be equal to, 1 over 2 ln u. But remember that our u, of course, don't forget to put your constant. Remember that your u there is just this part here. So where there's u, you replace with that. So the final solution will be 1 over 2 ln. You put your x squared, plus 2, then in absolute value brackets, like that, then plus c. So this is your solution for G. Let's quickly move on to H. So for H, we know that H can also be written as the integral of e to the power x minus 2 to the power negative 1. And we're differentiating this with respect to x, which is just the same as e to the power negative x minus plus 2. So the integral of this with respect to x is just nothing but negative e to the power x minus the power negative x plus 2, sorry. And then don't forget to put your c, because what I did here is just differentiated the power there, which gave me negative 1. Then I wrote the whole function there, then divided by negative 1. Then this is what I got. So we move on to I. I is saying the integral of 1 over x, then minus e. So we're differentiating this with respect to x. So we know to say the integral of 1 over x is nothing but ln x, and then minus the integral of any number. This e has no variable, so it's not raised to any variable. So the integral of e is just the same as the integral of any number, which means that we're just going to add x to e. Then we'll add our constant there. So this is our solution for this. We move on to J. So for J, as we can see that when we differentiate the denominator there, we're going to get the numerator as our solution. So meaning the numerator there can cancel with the derivative of the denominator. Hence, we're going to use U-substitution. So let u be equal to 4 plus sine x. U be equal to 4 plus sine x. So meaning du dx will just be equal to the derivative of a constant number is 0, but the derivative of sine x is cos x. So you make dx the subject there, when you make dx the subject, you're going to have du over cos x. So while there's dx there, I'm going to put this dx there, and then I'm going to have, this is what I'm going to have. I'm going to have the integral of cos x, and then where there is this, I'm going to put u. Where there is 4 plus sine x, I'm going to put u. Where there is dx, I'll put du over cos x. And you can see that this and that will cancel when we multiply, which means that I'm just going to remain with 1 over u du. So the integral of 1 over u is ln u plus c. So, but we know that our u is just 4 plus sine x, so I'm just going to replace with I'm just going to replace u with 4 plus sine x. Yeah, so this is the solution for this. We move on to k. So k here, as you can see, k, they even forgot to put x there in front of cos. So as you can see, k is also similar to j. When you differentiate the denominator there, it's easier for you to get something similar to the numerator. So in short, what I'm going to do, I'm going to make my u be equal to the denominator there, cos x. So meaning du dx is going to be equal to negative sine x. So my dx will now be equal to du over sine x. Of course, this is going to be negative. So while there's cos x, I'm going to put u. So while there's cos x, I'll put u, and then I'll multiply this by dx. Dx there is just negative du over sine x. We can see that this sine x and that sine x will cancel, and then we'll just remain with the integral of we'll remain with the negative integral of 1 over u du, which implies that we're just going to have negative ln u. The integral of 1 over u is negative ln u, is ln u, and then plus c. So this will now give us our answer to be negative ln. Our answer here will be negative ln. Where there is u, I'll replace with cos x. And then I'll say plus c. This is the solution. So we proceed. We look at L. L is equal to tan x. So L is just the integral of tan x. So with respect to x, so the integral of tan x, we know that tan x can also be written as sine x over cos x. Dx. But I'm sure you guys, you can see that this is just what I'm just from solving here. It's just this part here. So meaning the way I solved the previous question k is the way you solve this one. You can see that the integral of tan x here Oh, I thought there is tan x somewhere. Okay, we don't have tan x. Yeah, I thought there was tan x. I wanted to show you. So we can move on to the last question, which is this one. So the last question there is saying the integral of x minus 1 over x then dx. So these are independent terms, so I'm going to integrate them independently. So when you integrate x, you are just going to get x squared over 2. You just add 1 to the power and then divide by the new power there. And then the integral of 1 over x, remember, is nothing but ln x. So ln x is the integral of 1 over x. Then, and of course, don't forget to put your u there. Yeah, so we proceed to the next question, which is question 2. We're done with question 1. So question 2 is saying determine the integral of x, then that in brackets, then that. So in short, on this question, they are normally, okay, they're actually testing us on how to use the change of variables, rather how to use the this method I'm just from using on the previous questions, yeah, which is just U-substitution. Yeah, so in short, I'm going for this question here, I'll say to solve this question properly, I'm going to say let u be equal to what's in the brackets there, which is x raised to power 2 plus 3. So if that is going to be my u, meaning I'm going to okay, first, before I even do that, let me find du dx. So du dx is going to give me 2x. By now I'm sure you know how to find derivatives. So du dx is just 2x. So meaning my dx will now be equal to du over 2x. So now we can write our expression in terms of u. So this will just be equal to x, while there is x squared plus 3, I'm putting u, of course it's raised to power 2, and then I'm multiplying this by dx, this dx. So this dx is just the same as this dx. So this will be du, and then everything divided by 2x. Then of course this x and that x will cancel, so meaning we just remain with 1 over 2 outside, and then the integral of u squared du. How do you integrate this? So when you are integrating this, we're going to add 1 to the power there. So you're going to have first 1 over 2, and then you add 1 to the power, meaning you're going to have u to the power 3, and then over 3 there, over the new power, and then plus c. So our integral there will be 1 over 2 times 3, you get 6, and then u to the power 3 plus c. So where there is u there, we know that our u is nothing but x squared plus 3. So you just have to replace it there. So it's going to be like that. X squared plus 3 raised to power 3, and then you add it to c. So this is the solution for this question. We proceed to the next question. Let's see now what we have on the next question. Okay, so the next question is b. So b is saying the integral of that. So for this one, again, I'm going to choose my u to be x squared minus 1. So let u be equal to x squared minus 1. So du dx, so du dx will now be equal to 2x, meaning my dx there will just be nothing but du over 2 x. And then if I have that, I can now replace where there's x squared minus 1 with u in that expression. So I'll say x, and then the root of u, then du, where there's dx I'm going to put du over 2x. So you can see that this x and that x will cancel, then I'm just going to remain with the integral of, and then of course this u, the root of u can also be written as u over 1 over 2, and then this 2 can be removed outside. Then we're integrating this with respect to u. So when you integrate this with respect to u, you have 1 over 2, and then u, when you add 1 there, you get 3 over 2, and then you divide everything by the new power, which is 3 over 2, then plus c. So here you're just going to have something like this. It's going to be this will give you 2 over 6 u to the power 3 over 2, and then plus c. So here what you do again, you are just going to have you just replace this u with the original function there, and then you can reduce this to 1 over 3, and then while there is u, I'm replacing with but of course this u can also be written as, this part can also be written as u, and the root of u, and then to the power 3, and then plus c. So you can simplify it in that way. So meaning you're going to have something like this, the root of x squared minus 1, and then everything raised to power 3, and then plus the constant c. So this is how simple integration is. We proceed to the next question. So the next question is this. So in the same way, the next question, you do it in the same way. I'm going to say let u be equal to 2x plus 1. Du dx will just be equal to so our answer in C, du dx will just be equal to 2. So meaning my dx will just be equal to 1 over 2 du, which is just the same as du over 2. And then we can now replace our u in the expression. So we're going to have u, and then while there's dx, we put 1 over 2, so times 1 over 2 du, which can also be written as 1 over 2, and then the root of u can be written as u to the power half, and then du, like that. So when you integrate this, you're going to have 3, sorry, not 3, you're going to get 1 over 3, and then this will give you u raised to power 3 over 2, raised to power 3 over 2, then plus c. So I've just gotten like a second last step from the final solution. So the final solution will now give you 1 over 3, while there is u, you put 2x plus 1. So this is just the same as this. You can check how I did it from the previous question. This is what is going to be our solution. This is what is going to be our solution. So apart from this, there is also D here. Let us also see what we can do on D, how we solve question D. So how do you solve D? On D, again, you can use U-substitution. It's straightforward. You can use the change of variables. So here we can see that x, we can make this x to the power 4 as our u. So I'll say let u be equal to x to the power 4. So meaning my du dx, so my du dx is going to be equal to, when I differentiate this, I'm going to have 4x to the power 3. So 4x to the power 3 is what I'm going to get. So to find dx, I'm going to have du divided by 4x to the power 3, like that. So so here what we're going to do is, where there is x to the power 4, I'm going to replace with u, and then I'll replace the remaining things, the remaining things on dx. So where there's dx, I'm going to replace with this expression here. So I'm going to have the integral of x to the power 3, then cos u, and then times, where there's dx, I'm going to put du divided by 4x to the power 3. So this is going to give us, when you can see that this and that can cancel, so meaning I'm going to have 1 over 4 outside, and then the integral of cos u with respect to u. So when you integrate that, you're going to have the integral of cos u is nothing but sine u plus c. But remember, our u is nothing but x to the power 4, which is just this part here. So this is going to be sine x to the power 4 plus c. So this is how you solve this question. It is also just as simple as drinking water. We proceed to the next question. So even this question, you just use the same method, which is U-substitution, and of course your u is going to be what is in the brackets there. So I'll say let u be equal to x to the power 4 minus 2. So meaning my du dx, so my du dx is going to be equal to 4x to the power 3. So my dx is going to be equal to du over 4x to the power 3. So where there is u, we replace in that expression. So I'm going to have something like this. Our expression will be something like this: cos u, then we multiply by du, and then over 4x to the power 3. You can see that this and that will cancel, so meaning we just remain with the integral, 1 over 4, the integral of cos u, of course with respect to u. So this will be 1 over 4. Then when you integrate cos u, you get sin u, and then plus the constant. Then here we know that our u is nothing but x to the power 4 minus 2. So just replace our u with that, with x to the power 4 minus 2. Then everything plus c. So we proceed with the last question that we're going to do today, so that tomorrow when we meet on Zoom, we're going to do question 3 going up. Yeah, we're going to do question 3, then question 4. Yeah, so let's do the last question on this one. So we're going to have x. Yeah, so even there you can say let u be equal to 1 minus 4x squared, such that when I find my du dx, I'm going to have negative 8x. So sorry for that. So my dx will be nothing but equal to du over negative 8x. So in that expression we replace, we're going to have something like this, over the root of u, and then times, of course even on top, times du over negative 8x. You can see that this x and that x will cancel, then we're just going to remain with negative 1 over 8 this side, then integral of 1 over the root of u du. So this can also be written as 1 over negative 1 over 8, the integral of u to the power negative half, and then du, like that. So when you integrate that, you discover that your solution will be negative 1 over 8, and then this will be u to the power, so this will be u to the power half, and then everything divided by the new power, which is positive half, then plus the constant c. So this is just going to give you negative 2 over 8, and then u to the power half is just the same as the root of u, then plus c. So here we can see that we can reduce this fraction to 1 over 4, and then this u will just be equal to this part here. We said u is equal to 1 minus 4x squared, so 1 minus 4x squared is our u, then we say plus c. So this is the solution for this question. Thank you very much for watching the video. Make sure that you don't miss out the Zoom lecture tomorrow that we're going to have. We're going to start with question 3. Then if you have any questions, like I said during the Zoom meeting, that you can if you have any questions from what I've solved in this tutorial video, you can simply ask me on WhatsApp, and I'll be there to respond to you. See you in the next tutorial video.